Hey guys, today's lesson, the quadratic formula. Okay, the quadratic formula. So far in this chapter, we have been solving quadratic equations in a standard form um, by graphing, by making tables, by factoring, by using square roots, and by completing the squared. Now, the quadratic formula, it's another way of solving quadratic functions in a standard form. So the quadratic formula states, if ax squared plus bx plus c is equal to 0 and a is not equal to 0, then the solutions or roots are x equals negative b plus minus square root of b squared minus 4 times a times c divided by a. So we're going to substitute the values of a, b, and c into this equation. Okay? So when can we use the quadratic formula? To solve quadratic equation, we can always use the quadratic formula. Okay? As the same as to use completing the square, we can always use completing the square to solve quadratic formulas. Okay? So if we look at example 1, it says, example 1 says, find the zeros of f of x equals x squared plus 10x plus 2 by using the quadratic formula. Okay, they're telling us to find the zeros. So first thing is, we're going to make all of this equal to 0. That means x squared plus 10x plus 2 equals 0. Now let's define or let's identify the values of a, b, and c. Look, ax squared plus bx plus c. So what is the value of a in this case? X squared. We only have 1. It's an imaginary 1x squared plus 10x, 10, bx, b equals 10, and c equals 2. A equals 1, b equals 10, and c equals 2. Okay? Now let's write the quadratic formula. X equals negative b plus minus square root of b squared minus 4 times a times c over 2a. Now let's substitute. X equals negative b is 10, negative 10 plus minus square root of 10 squared minus 4 times a, 1, times c, 2, over 2 times a equals 1, 2 times 1. Now let's simplify. X equals negative 10 plus minus square root of 10 squared, that's 100, minus 4 times 1, 4, times 2, 8, divided by 2 times 1, 2. Okay? Now, we simplify this. I'm going to do it over here. Now we get x equals negative 10 plus minus square root of 100 minus 8. That is 92 over 2. Okay? 92 doesn't have a perfect square. Okay? So we're going to have to simplify. How do we simplify that? By finding the prime factorization. 92 is divisible by 2 equals 46. 46 is divisible by 2, that's 23. And 23, it's only divisible by itself. So that means we're going to take out x equals negative 10 plus minus square root of 2 squared times 23 over 2. We take out the 2, so we get that x equals negative 10 plus minus 2 square root of 23 divided by 2. Okay, so now negative 10 divided by 2, that's negative 5, plus minus 2 divided by 2, that's 1 square root of 23. So this will be our exact solution. Now, this means that we have two solutions, right? Negative 5 plus square root of 23 and negative 5 minus square root of 23. So we can leave our answer like this because square root of 23, it doesn't have a perfect square. So this will be our solution for the first quadratic equation. Notice in this case we have two real solutions, okay? Two real solutions. Now, if we look at part B, example 2, it says find the zeros of f of x equals 2x squared minus x plus 2. We're going to do the same process. We're going to make this equal 0. So that means 2x squared minus x plus 2 equals 0. Sorry about that. And let's find the values of a, b, and c. A equals 2. B equals negative 1. Sorry. And c equals 2. Okay, look. B is negative 1. Now we solve. X equals negative b plus minus a square root of b squared minus 4a times c over 2 times a. Now let's substitute. X equals negative 1, negative 1, b equals negative 1, plus minus square root of negative 1 squared minus 4 times 2 times 2. A equals 2, c equals 2, right? Over 2 times 2. Now let's simplify. Negative times negative 1, positive 1, plus minus square root of negative 1 squared, 1, minus 4 times 2, 8, times 2, 16, over 2 times 2, 4. Okay, now we're going to simplify. So we get x equals 1 plus minus square root of 1 minus 16, that's negative 15, over 4. Now we have a negative square root, so that means x equals 1 plus minus square root of 15 times square root of negative 1 over 4. Square root of negative 1, that's I. So that means that x equals 1 plus minus square root of 15I over 4. And that will be our solution. Okay, we cannot simplify anything here. So that means that in this case we have two solutions. Okay, it would be 1 plus square root of 15I and 1 minus square root of 15I. In this case, we have two imaginary solutions, two complex solutions, okay? Okay, so in example 1, we have two real solutions. In example 2, we have two imaginary solutions. Now, if we look at the part inside the radicand, b squared minus 4ac, b squared minus 4a times c is the part of the quadratic formula, is a part of the quadratic formula known as the discriminant. Now, the value of the discriminant will determine the number of roots that we're going to have, the number and type of roots. So, if the discriminant, if b squared minus 4 times a times c is greater than 0, if b squared minus 4 times a times c is greater than 0, then we're going to have two distinct real solutions. So if you notice in example 1, the value inside the discriminant was equal to 92. 92 is greater than 0, so we have two real solutions. Now, if the discriminant b squared minus 4 times a times c is equal to 0, if that is equal to 0, then we have one distinct real solution. And if the discriminant b squared minus 4 times a times c is less than 0, then we're going to have two distinct non-real, that means imaginary, complex solutions. So if the discriminant is greater than 0, two real solutions. If the discriminant is equal to 0, one real solution. And if the discriminant is less than 0, two imaginary solutions or non-real complex solutions. Okay? So let's do example 3. Example 3 says, find the type and number of solutions for each equation. How are we going to find that type and number of solutions? Is by using the discriminant. So in part A, we have x squared minus 6x equals negative 7. First is to write this as x squared minus 6x plus 7 equals 0. Okay? So we know the value of A, B, and C. A equals 1, B equals negative 6, and C equals 7. Okay? So now let's use the discriminant. B squared minus 4 times A times C. Okay? So B equals negative 6. So that means negative 6 squared minus 4 times A times 1 times C times 7. Negative 6 squared, that's 36, minus 4 times 1, that's 4. 4 times 7, 28. 36 minus 28, that's equals to 8. Okay, if we compare 8 and 0, we notice that 8 is greater than 0. Okay? So what happened when the discriminant was greater than 0? The type of solution will be real solutions. real solutions. And number of solutions, when it was greater than 0, 2. Okay? Now, in part B, we do the same. We pass 9 to the other side, and we get x squared minus 6x plus 9 equals 0. Okay? So we know that A equals 1, B equals, negative 6, and C equals 9. So we use the discriminant, B squared minus 4 times A times C. We substitute negative 6 squared minus 4 times 1 times 9. 6 squared, that's 36, minus 4 times 1, that's 4, times 9, 36. 36 minus 36, 0. If we compare 0 with 0, we notice that they're equal. So what happens when the discriminant is equal to 0? Type of solutions, real. Number of solutions, 1. Okay? And finally, the last step, the last example. Okay, we get x squared minus 6x plus 11 equals 0. A, B, C. A equals 1, B equals negative 6, C equals positive 11. Okay, now we use discriminant, B squared minus 4 times A times C. B, that's negative 6 squared minus 4 times 1 times 11. Negative 6 squared, 36, minus 4 times 1, 4 times 8 times 11, 44. 36 minus 44, that's negative 8. If we compare that discriminant with 0, we notice that negative 8 is less than 0. So what kind of solutions are we going to have? Non-real solutions. And how many? 2. Okay? Okay, and that's how the discriminant is very helpful to know the type and number of solutions. Now, if we look at the table on page 360, here we have the methods for solving quadratic equation and when to use these methods. So here we have graphing. When do we use? Only to approximate solutions or the number of solutions is needed. So when are we going to use it? Sometimes. Factoring. When are we going to use factoring? When C equals 0 or the expression is easily factorable. That means also sometimes we're going to be using factoring. When can you solve quadratic equations by square roots? When the variable side of the equation is a perfect square. When that happens? Sometimes. Completing the square. When are we going to use completing the square? When A equals 1 and B is an even number. Okay? And quadratic formula. When do we use quadratic formula? Numbers are large or complicated and the expression does not factor easily. So that means that we can always use the quadratic formula. So that's it, guys. This is another method of solving quadratic functions by using the quadratic formula. Okay, guys. See you next week.